So what if everything we think we know about intelligence, in our own heads and in the machines we're building, is just kind of built on a flawed idea? Well, today we're going to dive into a completely different way of looking at the mind. And it all started with a really surprising confession from a top AI researcher. All right, let's get into it. Our story starts with a guy named Blaise Aguirre-Yarkis, a researcher over at Google. And for years, he was a huge skeptic. He was convinced that for us to get to real, true artificial intelligence, we'd need some massive new scientific breakthrough, probably something inspired by the crazy complex wiring of our own brains.
And here's the question that really bugged scientists like Blaise. You look at these incredibly powerful AI models, right? But under the hood, they're basically just incredibly good at guessing what the next word in a sentence should be. The idea that this one simple trick could lead to actual, genuine thought? Come on, it just sounded ridiculous.
He's pretty open about it. He says his view back then was the standard scientific opinion, but he admits there was also a little bit of snobbery to it. All that Silicon Valley talk about just throwing more computers at a problem? It felt way too simple. It just couldn't be that easy, right?
But then, things started to change. As he saw more and more evidence piling up, he came to a pretty stark conclusion. His old way of thinking was just plain wrong.
So what was it? What flipped the switch for him? Well, it started with an AI called Mina, which was showing these little sparks of real understanding. It could even tell jokes. Then its successor, Lambda, came along and was even better. But here's the kicker. There was no single eureka moment. There was no genius new algorithm. The secret ingredient? It was just scale. A truly massive, enormous amount of it.
And that realization led to this huge, fascinating question. If you can create something that looks a lot like intelligence, just by scaling up simple computations, could that be how nature did it too? Could that same principle actually explain, us?
And the answer might be found in this really powerful idea from biology called symbiogenesis. Forget what you know about survival of the fittest. This isn't about competition. It's about cooperation. It's when simple things team up to form newer, more complex things, with all the pieces working together at the same time.
Turns out, symbiogenesis is the engine behind pretty much every major leap forward in the history of life. You see it when simple cells first merge to create complex ones. You see it again when those cells formed the first multicellular creatures. And you even see it in how we've built our own complex societies. It's like a ladder of cooperation, each step building on the one before it.
Okay, so this is the really critical idea. For decades, we've thought about progress in terms of Moore's law. A single computer chip just gets faster and faster. But what we're seeing in both life and modern AI is a totally different playbook. The individual parts don't necessarily get faster. You just get way more of them all working together in parallel.
And this leads to an even bigger, more mind-blowing thought. What if computation isn't something humans invented at all? What if it's a fundamental principle of the universe, one that life has been using for billions of years?
This quote just nails it. We didn't invent computing any more than we invented electricity. We just figured out how to harness it with silicon. It completely reframes computer science. It's not just engineering, it's a natural science, like biology or physics. We discovered it. We didn't create it from scratch.
And here is where it gets truly wild. Check this out. Back in the 1950s, way before we knew the fine details of how DNA works, a brilliant computer scientist named John von Neumann sat down and tried to figure out, just using logic, how a machine could build a copy of itself. He theorized it would need these three parts. Decades later, guess what biologists found inside our cells? The exact same system. He basically reverse-engineered the machinery of life without ever looking at it.
Which brings us to this absolutely staggering conclusion. The very act of living, of making a copy of yourself, is at its core a computational process. Biology isn't just like a computer. At the most fundamental level, it is one.
Okay, so if that's all true, what on earth does it mean for our future with AI? Well, if you start looking at it through this lens of symbiogenesis, the entire picture it changes completely. It stops being a story about us versus them.
First, let's just quickly touch on why nature loves symbiosis. It really comes down to efficiency. Thinking is hard work. Your brain, right now, is burning through 20% of your body's entire energy budget. And in kids, it's almost half. So evolution is always looking for a cheaper way to get smarter. And this is such an important distinction to make. We usually think of evolution as this brutal, zero-sum game where one species wins and another one loses. But symbiogenesis is different. It's creative. It's how entirely new kinds of things come into existence, opening up brand new ways to live. It's about making a bigger pie, not just fighting over the same old one.
So here it is, the big radical idea. What if we stop thinking about AI as this separate alien thing that's coming to replace us? What if instead, we see it as the next step in a long history of humans merging with our tools? Maybe AI isn't an invader. Maybe it's our newest symbiotic partner.
And if you look at it that way, the future starts to look a lot more hopeful. Instead of a fight for survival, you can start to imagine a world where our combined, scaled-up intelligence helps us crack the really big problems. Things like clean energy or fixing our environment. The way forward isn't less intelligence, it's more.
Seriously, this shift in thinking from focusing on individual competition to seeing the power of symbiotic systems, it's an incredibly powerful tool. And it doesn't just work for thinking about AI and biology.
So let's take this exact same idea, this mental model of symbiotic systems, and apply it to something completely different but just as complicated, our global economy, and how it relates to the natural world.
For the longest time, our economic models had this huge blind spot. They were really good at counting things like factories and human labor, but they treated nature as if it were just free wallpaper, an infinite resource we didn't have to worry about. Sound familiar? It's the same kind of mistake we made with intelligence. We were missing a massive piece of the system. The new, better view sees that nature isn't just wallpaper, it's a foundational asset that our entire economy is built on.
And the price we've paid for that old perspective is it's staggering. In just 45 years, we lost a third of the planet's wetlands. Why? Because our economic system literally couldn't see their value. Their value in preventing floods, in cleaning our water, in storing carbon. That's the real-world cost of having a flawed model.
And that really brings us to the heart of this whole explainer. It doesn't matter if we're talking about artificial intelligence or the global economy. The path forward is about seeing the bigger system. We are not separate from our technology, and we are not separate from nature. It's all one interconnected system.
So what's the big takeaway here? By just shifting our perspective, by moving from a mindset of competition to one of cooperation, from seeing isolated parts to seeing interconnected systems, we can find brand new ways to solve our toughest problems. We've seen it with AI in the economy, but it doesn't have to stop there. So the question I really want to leave you with is, what other huge challenges could we solve if we just started to see the world differently?